Hello everyone, my name is Dmitry Vinnik and I'm a developer advocate on the Facebook open source team. Today we'll talk about concurrency in Java and I'll try to use some of the Facebook open source projects in Android space to showcase lessons that we will learn today in this talk. So let's get started. Thank you everyone for joining. As I mentioned, my name is Dmitry Vinnik. You can read all my other content on my Twitter account, Dmitry Vinnik, and on my website, dvinnik.dev. So without further ado, let's get started. What are our goals for today? The goals are fairly straightforward. We'll talk about concurrency in its forms. We'll discuss misconceptions in concurrency and also workflows, how and why they're used in Java. So the big question to ask is why concurrency? Why do we even need to talk about it? Motivations are fairly straightforward. I'm sure you've heard of them. It's the fact that we all have multi-core machines these days, the abundance of microservices. It's been around for ages now, and also the cloud computing services like AWS, Azure, and Google Cloud. So all those services obviously provide you with as many resources as you'd like, and the concurrency just goes along with it, so you can utilize more. So what's the conclusion then? After me bringing up those motivation factors. So the conclusion is fairly straightforward. Concurrency is a new reality. Concurrency is the reality. It's not something you have to adopt anymore. It's already here. So what's in it for us though? Yes, it's great that the world is ready and that's how people operate, but why would you need to adopt concurrency? The benefits, again, just three of them that I'd like to mention. The fact that there is no idling of resources, the fact that you have multi-core machines, but you don't use those resources is kind of wasteful. It improves user experience. You don't have those freezing threads, the frozen UI while you're waiting on something to load. You can't ever close the pop-up. You don't want to have that. That's why we have different threads running in parallel. And the fact that it really forces you to think about abstractions. Because as long as you have a fairly safe abstractions in your code, you can actually utilize multi-threading fairly easily. But unfortunately, it's not just good parts when it comes to concurrency. Otherwise, there wouldn't be a need for this talk whatsoever. There are complexities. The fact that thread safety has to be considered, the race conditions, the liveness, when do you remove the thread from the pool, when do you reuse it, performance. It's not just a given, add another thread to your machine and your service and have an improvement 2x or 10x just by adding a couple of threads. It doesn't work like that. And also really you have to consider about other stages of software development lifecycle. How do you test concurrency? That's a big issue of its own. But even though it's complex, it's actually beneficial. I mean, as I mentioned, the motivations and benefits, and I would even call it beautiful. Concurrency is beautiful. It reminds me of the fact that concurrency very much like sharks. When we hear about sharks, we worry about them, how dangerous they are, but really it's the fact that we don't really know about them well enough. The same goes for concurrency. As long as you're not aware of how to use it, how it can improve your workflow, try to avoid them. So, concurrency in sharks, when I read the Brian Goetz Java concurrency in practice, at first it was, scary to me. It's so complex, but as I was reading more and more, I realized that concurrency is extremely useful. And the book, again, made an impression on me. The same goes for this book by Jean-Marie, The Shark, Fear and Beauty. The same kind of concept there. I would want to try to use this talk for you to remove this fear and of avoiding concurrency and begin to admire it like I did. And this journey from fear to admiration is what will create our agenda. We'll begin by talking about single threading in Java, then we'll discuss multi-threading, concurrency in Java, and ultimately we'll finish by discussing workflows. But as I mentioned, we'll begin by talking about single threads. So another important question to ask, do I even care? I've given you a couple of motivation factors, benefits, also complexities. Still, I might have not convinced you, right? You might be asking yourself or telling yourself that my app is single threaded. I don't even need to make it more, performant. It might be too complex to think about concurrency. And that's why I, regardless of whether you'd like to adopt concurrency itself, I always push people to consider implementing design for concurrency. It's the fact that you stop programming by coincidence. You don't just write software and assume it will work. You design by contract. You know what to expect from your code. You try to avoid temporal coupling, which is basically when, depending on the order of operations, you actually modify the state of the object. Imagine that you use the HTTP request, and depending on whether you've made a post or get call on it, you would expect the response to be inside of the object. That's a good example of what temporal coupling is. So you need to really work on making it immutable and atomic as possible. So meaning regardless of how many threads interact with it, one thread can't change the object for another thread. It will use its own copy or utilize other techniques to think for concurrency first. And that's where I'd like to talk about multi-threading a bit more. And just regardless of Java or you use something else, It's just the conceptual idea of multi-threading. So multi-threading, what forms can it take? There are so many different ideas and forms, and that's why I'd like to discuss concurrent form, parallel form, and asynchronous forms. And I'll begin with the most commonly used, concurrent form. So concurrent form implies that it's working with multiple tasks, but it doesn't physically require multiple cores. But at the same time, it's logically simultaneous tasks. What it means is that if you had an old machine and you didn't have multiple cores like my Mac laptop would, you would have a perception that the tasks completed parallel from one another, but in reality it's actually just switched resources around. So is it too abstract? It might be too abstract just to see the diagram. I'd like to just show you some example, and I like to use try to think of developing an app. And what do you need to develop an app? You need coffee and you need the laptop, right? And so when it comes to that, imagine you have a single thread, a person named John, and John needs to code and drink coffee, code and drink coffee. And even though it's just a single person, he ultimately completed two tasks, so two simultaneous tasks. He drank his cup of coffee, but he also completed the app. So it seemed like it's logically simultaneous tasks, but there's only one John, right? So he had to use his resources and switch it around. So ultimately he finished two tasks. Parallel form is a bit more complex. What it means is that it still have multiple tasks, multiple subtasks. Some people think of it. In other words, imagine you have a complex mathematical algorithm running, and so what you do, you split it in multiple subtasks that ultimately do their own part of the equation. Then they come together and do the summation, or do the addition, do subtraction, whatever necessary. It's physically simultaneous, so it does require multiple CPUs, which again, we have enough these days for the most part. Let's again try to apply it developing an app. And here we actually have Jenny. And Jenny, she's not just a single person, you can think of it. She's ambidextrous. She has ability to use both hands at the same time. So in this case, you can think of Jenny as two people, two threads, because using one hand, she can keep drinking coffee, finishing that one task, but with another, she can just keep coding. So you ultimately have this physically simultaneous process, completing two subtasks and ultimately having an app. And it brings us to asynchronous forms of multi-threading. So when it comes to asynchrony, it's really an idea of fire and forget. It's non-blocking tasks, but they do require multiple CPUs. Think of, you go to withdraw money from ATM, and while your main operation is to withdraw the money, asynchronously it might fire a logging operation somewhere, so the people who manage ATM know that the transaction happened of some sort, some metadata, right? And that separate task that doesn't affect the main process of withdrawing the money has been triggered, and that's where asynchrony come in play. It's fire and forget. So let's think again. Developing an app, we have coffee, we have laptop, but the big question to ask is, where did the coffee come from, right? Who does that? Who makes it for you? And this is where Coffee Machine, or our great friend Henry, comes into play. And Henry is so amazing. He just keeps bringing you coffee while you work on your app. In this case, John is a person who's not an ambidextrous developer. He develops an app but also drinking coffee. At the same time, parallel to his work, Henry just keeps making coffee, bringing it over without actually stopping John. So it's been quite abstract so far. Let's actually look at concurrency in Java. So without further ado, let's get started with concurrency in Java in particular. First, there were runnable and threads. That's probably where most of the concern and avoidance of concurrency happen for majority of beginner Java developers or even senior Java developers. And so when it comes to runnable and threads, they didn't take any input, they didn't produce any output, and they gave you no exceptions. An example I have here, some pseudocode where you have a process of drinking coffee. It's a simple run operation that you have to override and implement in one way or another. But really, when you trigger it, you have very little control over runnable itself. I'll give you a quick demo with Fresco to just showcase runnable and threads and how they're used. Fresco is a great image management library on Android. Imagine you on a slow network and you can't show an image completely in a high resolution right away. And so what Fresco would do is it will show a placeholder and slowly improve the quality of the image, will handle caching and other complex things for you. That's what Fresco is. And to use Fresco, it's fairly straightforward. You would have to add a create functionality. You would initialize the Fresco, then you would add to your layout a simple drawy view as an example, And then what you would do is that you will just show the image. Fairly straightforward, but then it will actually, handle caching, as I mentioned, a placeholder image for you. So now let's take a look at a small example of Runnable and threads with Fresco. Imagine if I had a simple adapter for Fresco image handling. I would use something called run on UI thread that's common to activities in Android, and I would supply a runnable to it, and it will handle in the run refreshment of the UI whenever data on the screen would change. That's what runnable are, and they still heavily used even today, while concurrency, as I'll show in this talk, has improved significantly in the past couple of years. So fortunately, after Threads and Runnable, JDK 5 was released, and JDK 5 introduced Concurrency API. Concurrency API had multiple, ways to, improve your experience, developer experience, when it comes to concurrency. One of the big, additions were thread local, atomic operation, thread safe collections, and a lot more other things. So let's take a look at thread local, what the heck that is. Thread local is a great way to confine resources. It allows you to request or, initialize different instance of the source of a resource, like for instance simple date formatter, depending on the thread that accesses the thread local. That being said, it still doesn't come for free. There are some opportunities for memory leaks, and the fact that you should be still avoiding global fields like thread locals that really allow you to do that. Atomic operations are also great addition to the concurrency. What it does is it helps you with compound operations, the inline incrementation that you might have seen before, especially with for loops, like I++. It's actually a compound operation. In the parallel flow, you would have, it would have to retrieve a value, add another value, and add them up. It's three different operations together, and if you were just to plainly access and do those kind of addition, it will lead you to potentially having race condition there. That's why atomic operations are great for that. They will make sure that incrementation, subtraction, or even more complex atomic reference to a website, an example that I have here, will be handled for you. So it allows you to have a speed, and also it have compare and swap operation that handled for you in the background. And thread safe collections, with collections in general, adding values to it and retrieving values from the collection are complex for different threads. That's why with thread safe collections like concurrent hash map, you have, again, a great handle on compound operations. Getting a value, changing it, and then putting it back in the collection, it's not that straightforward. And here you have a configurable concurrency in action. You can control how big the collection can be, the density, number of threads that you think might be accessing this collection, and you don't have to create this synchronized block that really just blocks your threads, and you lose so much when it comes to concurrency. That's why just plainly using this collection save you so much time. And I'll give you a quick demo with Spectrum, another Facebook open source project, just showcase how one of these collections can be used. Spectrum is another open source library from Facebook that focuses on Android and actually other platforms as well. But in this example, I'll use Spectrum for Android. What Spectrum does is it handles transcoding of images for you. In other words, it will handle, in this scenario, complex image uploads for you, making sure that resolution is actually kept as high as possible with a small size as possible. So to use Spectrum, you would have to simply add initializer to onCreate function. And then you would have to specify what kind of plugins you will use, basically what images in this example you will use, like JPEG, PNG, etc. And in our case, if you wanted to use it, you would just invoke Spectrum to transcode input file, output, and then produce output stream, specify, JPEG as an output, and so on. So you will see the documentation for Spectrum is quite extensive and I would say great. But if I were to apply concurrency API for Spectrum, you would see that I would return a concurrent hash map that I showed in my slides. I would have imagine I wanted to process duplicate images, but I don't want to just upload photos to my app. Instead, I want to just have a quick lookup on my map, but because I have a concurrent application, I want to make sure I don't have a race condition. And the only thing I would have to do is my already initialized transcoded images map, I would look up by name or an ID for the image. And if it's not there yet, I'll add it to the list. Otherwise, I'll just retrieve it and use for my purposes. So again, quick look at what the concurrent hash map can do for you. So we talked about concurrency really briefly. I'd like to now jump into workflows, and not just workflows in Java. And that's where, a big question to ask, where do we start when we talk about workflows? And it's important to start at other languages, at other implementations of that. Promises in JavaScript might have been the first time I myself personally heard of workflows. And we'll talk at Future and Callable, Executive Framework, and it will bring us to CompletableFuture. So promises in JavaScript, you don't have to think long for how to scare a web developer. You just have to bring up the callback hell that people had to encounter. When you call an operation, then you wait for it to complete, then you have to handle on success, on failure, try to even catch exceptions. It's been really complicated in the past. Fortunately, with creation of promises, now it's very much like chaining of operation. You call a task, you call an operation, and then depending on how it works, you either handle a success or a failure or ultimately an exception. And as you can see in this example on the screen, this pseudocode, you can see how much shorter and actually maintainable this code becomes. When it comes to Java, Future and Callable are very important. What runnable is for a thread, basically this power horse, the thing that does the work. Callable is what does work for Future. Callable is really a big improvement, step forward from runnable. It doesn't still take any input, but it produces an output and has an exception that you have to handle. In this example, imagine that you have a process that sometime in the future someone has to fix a bug. That's what filing a bug is, right? You expect it to be fixed, ideally. So imagine you have, you have to override a call operation. It will throw an exception, someone will fix a bug, and then depending on success or failure, you will handle it appropriately. But also you have to handle an exception. But the future, again, it's similar to threads, but using callables. It's something that's completed in the future. That's what the name comes from. Executive Framework is what it relies on. And I'll talk in depth about what Executive Framework is in the later slides. So executive service, just imagine that it's a thing that we are aware of. You have an operation, completed to do. We have plenty of to-dos in our code base. So we have something that someone will fix in the future. So you have a completed to-do written, and then you have a future that you invoke on the executor service, and you say code to be written, and you wait for that code to be written. That's what Future will produce, actual code, as you can see in this pseudocode. Future sounds great though, but how do we use it? That's where Executive Framework is essential. Executive Framework really helps with things like thread management and implements this declarative model, things that you don't have to think about how something works, but it just works. So you focus on the task that you're trying to complete rather than focusing on how that task is done. That's where Executive Framework, what the Executive Framework does for you. It handles that thread management for you. It really relies on a thread pool. That's what behind the scene Executive Framework is all about. Thread pool is really what does the thread management and thread configuration. Here's an example of actual constructor that the thread pool executor looks like in the Java itself. It has so many arguments, and you wouldn't want to initialize it on your own unless you build in a custom Executive Framework, executor service. That's why, regardless of that many arguments, we have factories, and factories are amazing. I can't talk about executor service without talking about factories. Executor factories, there are plenty of them. There's a single thread pool, great for just, experiments. Cached thread pool, something that you would use for small operations, like, you're trying to crawl a web page. You have multiple threads that scroll different pages. That's where cached thread pool will come into play. Fixed thread pool, you know exactly how many threads you'd like to utilize. It's great for some, again, complex and resource-heavy mathematical calculations. Scheduled thread pool, think of it like Chronos or just constantly monitoring service that you might like to trigger. And work stealing pool is actually how streams in Java work. They just throw around resources, utilize whatever pool already has. Great thing that you don't really have to worry about it too much on your own. Just rely on the ones that I've just mentioned prior. So executor and thread pools, it ultimately produce this thing that I've mentioned before, executor service. Executor service is what allows you to have these asynchronous tasks, these futures, but ultimately it's thread pools. In this example, as I mentioned before, you'd like to crawl a website, you have a crawler service that relies on the factory for cache thread pool, have a list of URLs you'd like to crawl, and you just submit those operations to executor. It launches them as soon as you invoke submit, and you can just collect those future pages and ultimately wait for them to complete. I'll give you a quick demo with Fresco as an example of how to use executor service. So let's give it a go. Another quick look at Fresco and how it can be used with features and executable services. In this case, I have an image pipeline, something that Fresco relies quite heavily. It has a great implementation for something called data sources and its own executors. The only thing you have to know is just how it handles images. And so if I were to subscribe to a certain data source, the only thing I would really need is the bitmaps and executor. In this case, caller thread executor that I would retrieve an instance of. That's how it's actually used in Fresco. Good production ready example. The important question to ask, are we done yet? I mean, the title of this talk is Completable Future, so you can guess we'll talk about something other than future, because it's not perfect. Future pitfalls, some of them are blocking operations, there is no result chaining, so it's not real promises. A future combination, combining multiple futures that running in parallel, and exception handling is fairly complex when dealing with futures themselves. So blocking result retrieval, what does it mean? So when you call a get on the future itself, it blocks the process, right? And you actually have to handle, interrupted exceptions and things of that sort. So there are some ways to handle it, but ultimately you're losing on a lot of benefits of asynchrony. And also you have to be careful and always use the timeouts. You don't necessarily have just a continuous block with no end whatsoever. That's why you call get with a timeout of some sort. There is no future chaining. You can't wait for future to complete and just keep writing like a stream style code. You have to make a call for it, wait for task to complete, and only then handle it some one way or another. For instance, you have a Kanban board, you have a developer that writes a code, have to wait for that code to complete, and only then you can test it, which kind of makes sense. But if you will write it as the two separate blocks, it becomes kind of harder to maintain because you context switch. That's why future chaining are so important. Exception handling, another thing I want to just bring up, it is complex. Multiple exceptions to handle, interrupted exceptions, executor for exceptions, timeout exceptions. Lots of things when you're dealing with futures. And you have to handle them completely different depending on what exception you're dealing with. So there are many issues, but no worries, right? We have CompletableFuture to help us. That's why this talk is called CompletableFuture. And that's where we'll discuss that in length. So CompletableFuture basically gets you everything that Future has, but now has additional interface implementation, which is completion stage. It allows you to transform, compose, chain, and combine. Basically everything that Future had issues with, CompletableFuture allows you to handle. Those pitfalls I've mentioned before with Future, we're handling them with CompletableFuture. Transformation and chaining. It allows you to have workflows. It relies on something called fork join pool that I brought up earlier really briefly, but basically the way you write it, you can supply a sync, basically trigger an operation like developer wants coffee, so a person has to brew it. While that brewing is happening, developer can just keep doing their thing, so it doesn't have to stop the person from working. While that's happening, as soon as coffee is done, you can invoke then apply, basically drink the coffee when it's ready. If that's done, you can have more complex operations like, you can have a separate pool just to handle that operation, but it's just for folks who have a more intense concurrency that models in place. Controllable futures. You can now control when the operation is done. And so in this case, you can control when the future is completed. If it's not yet done, you can say, give me whatever and specify default value, or you can forcefully complete it through another thread, even if you'd like. In this case, I complete latte making, which just give me an espresso, give me whatever you've done so far if you're not yet done, and I'll take that and I'll go with that. You can have multiple futures controlled, right? You have all off or any off operation with CompletableFuture. Here, it's perfect for, let's say, you're trying to run a WebDriver test for multiple browsers, Firefox, Chrome, and IE. And the only thing you really have to invoke is all off and just run those asynchronous threads in whatever way, shape, or form you'd like. And then just wait for those to be done. You can see how many processes are still working. You can control them even more fine-grained if you'd like, but just amount of control it gives you is outstanding. You can also combine your tasks, right? You can collect your results. You can run them either synchronously or asynchronously. Imagine you have two teams asking you for APIs. Before you work on it, you don't want to just rush. You want to make sure you have those requests properly filed, and only then you'll put them on your Kanban board or whatever you use. And so you'll wait for those teams to complete their operations, which is filing those requests, and only then you'll begin working on them. That's where then combine operation come into place. It's just that powerful. But also exception handling. It's, as I mentioned, been very complex with futures. Here you have a very much try-catch finally flow, but using CompletableFuture. In this case, if an exception is thrown, you have exceptionally call to make, and this is where you know, if exception happen, it will go there, handle it whatever way you want. You can fail it completely, you can propagate the exception, you can just return some value, or you can handle it. It's finally, basically. In that case, if the exception happen, it will go on its own if statement. If not, you can proceed in whatever shape form you'd like. Again, great. The paradigm that you don't have to switch from your regular coding, non-concurrent coding, with a CompletableFuture, just outstanding. And to give you a quick demo, I'll use Litho, another open source project from Facebook, to showcase CompletableFuture really briefly. So another example of Facebook open source library that I'll like to showcase really quickly is Litho. Litho is a great declarative framework for UI in Android. What it does is helps you to easily and quickly create UIs for Android applications. In this example, the only thing you would need to do to have, Litho working for you, you would need to initialize as SO loader, and then you would have components. It's heavily inspired by React, as you can guess. That's where components come from. And in this case, I just show you how, text component might show up on the UI for Android. We have a great tutorial on the Litho website as well, fblitho.com. And so, to give you an example of how it's used with CompletableFuture, how Litho can utilize CompletableFutures, imagine that I, for some reason, whatever reason might be, want to randomly change the text on the component. And so what I would do is that I would use CompletableFuture.runAsync, which basically triggers operation that I don't care for result, really. It produces void as its return. And what I would do, I would retrieve a text component, change it text, and basically rebuild the UI. But again, I would be triggering it randomly in a separate thread. It might be some just funny small app that you might be building, and that's where CompletableFuture will come into play quite usefully. So I always like to end my talks with call to action. Try to embrace concurrency. As I mentioned before, it's already here. It's a reality that we all live in. Review your application. Even if you're not ready for concurrency, think about designing for concurrency. It will bring you the benefits just by itself. And just continue learning. Concurrency is one thing. Reactivity is another, very popular concept that's been discussed for ages now. So continue learning when it comes to that. Don't just be afraid of a concept just because you've used it before, like Threads and Runnables. There's a lot of work being done around that. So, my name is Dmitry Vinnik. Go to my Twitter, my blog, LinkedIn, or just email me directly if you have any questions. Thank you so much.